What's up, guys? So this is going to be a short video on how to do vectors. So this is a very simple problem right here. This is just super basics of five. This is vector forces, sorry. Not just vectors, vector forces. And it's a little introduction into just force. So let's start with our introduction into force. Force will be seen as F, which is going to be equal to mass times acceleration. So that will always be our force formula, mass times acceleration. So a 5 kilogram object initially at rest, right? So velocity initial is 0. So there's an object right here. It's 5 kilograms. And it has a 10 Newton force to the right. And a 5 Newton force to the left. So this is super easy. What is the net force on the 5 kilogram object? Well, anything to the left or down is basically just a negative value, right? Sorry, that's a terrible negative sign. A negative value. So it's just, what's the net force? The net force is combining all the forces that are on an object. So 10 plus the negative 5, right? So just 10 minus 5 is equal to a positive 5 newtons. And if you just think about this logically, there's 2 times the amount going to the right. So if there's 10 newtons going to the right and 5 to the left, then there's 5 left still going to the right and 0 on the left. So there's 5 newtons. That's the net force of the 5 kilogram object, and it's going to the right. So in this problem, the initially at rest and the 5 kilograms didn't even matter. So sometimes it won't, but this is a very simple, basic problem. Let's get into a more advanced one right now. So in this problem, there's a 50 kilogram object initially at rest, which experiences a uniform acceleration. And uniform acceleration kind of just means that there's just a constant speeding up or slowing down. So it's initially at rest and travels 100 meters in 4 seconds. So it's speeding up a constant amount in 4 seconds. What is the force acting on the object? So what we're gonna have to do here is, let's see. So we're gonna actually have to use some kinematics. So initial velocity is zero. The change in x is 100, and the time it takes is 4 seconds. So what we need to find is this acceleration, right? Because force is equal to mass times acceleration. Well, we have mass. It's asking for the force, but we don't know acceleration. So we use these other numbers, these other values, and initially at rest to use kinematics to ultimately find this missing component. So what do we not have here? We do not have final velocity, right? So right here, so we're going to use that equation. So change in x is equal to VIT plus 1/2 AT squared. So this is going to be 100 is equal to 0 times anything 0 plus 1/2 A, we do not know. 4 squared is just 16, right? So, and then 16 divided by 2 is going to be 8. So it's ultimately 8A is equal to 100. So divided by 8, and our acceleration is going to be equal to 12.5 meters a second squared. Right? All right. And there should be a period there. All right, so 12.5 meters a second squared is our acceleration. And so now we just solve F is equal to M, which is 50 kilograms. And mass should always be in kilograms. If it's in grams, you divide by 1,000, right? So 50 times 12.5. And our force is going to end up becoming 625 newtons. So that's what the N is for, is newtons, right? Like Isaac Newton, because he discovered force, so he named it after himself. Selfish bastard. But, just kidding. force is equal to 625 newtons. So just get used to that. Force is always going to be with the N as your label. So an object initially traveling at 20 meters a second accelerates to a complete stop within a distance of 300 meters. So usually what you would expect is for them to say decelerate because we're slowing down, right? We're at 20 meters a second and then we're at a complete stop. So we just slowed down, but the College Board and physics just kind of like to trick you a little bit, and they'll say it accelerates, which should theoretically mean it's speeding up, but in this case it is actually slowing down. So you want to think a little bit while you do these problems. So initial velocity is going to be 20 meters a second, and our final velocity, because it comes to a complete stop, is 0. Now it's a distance of 300 meters. If the force on the object was 200 newtons, what is the mass of the object? So basically what we have here is we have F, but we don't have mass or acceleration, but we're trying to solve for mass. So what do we need to find first? If we have force, we're trying to solve for mass, we need to find acceleration. So we use these numbers right here to find acceleration using kinematics. What do we not have? Well, we don't have time. So let's just do final velocity squared is equal to initial velocity squared plus 2 times acceleration times the distance. So 0 squared is just 0. 20 squared is going to be 400 plus 2. We do not have our acceleration, and then this is going to be 300. So this is right here, 600A. Let's subtract 600A and bring it onto the other side, right? So now we have negative 600A is equal to 400. So you guys might be freaking out right now, like, oh, why do we have a negative on one side and a positive on the other side? Well, it actually makes sense because this acceleration is slowing down to a stop, which means that it should be a negative value. Acceleration is going to be a negative number, which is going to be just 2 divided by 3, which is going to be 0.67 roughly, right? If we round. So we have the 0.67, and basically this negative doesn't really matter. So our acceleration is negative 0.67 meters a second squared. So we're going to use our F is equal to ma equation because now we have acceleration and force. So we have a positive 200 mass times negative 0.67. This is actually coming from negative 2/3 right here. So what we can do is divide by the negative 2/3, divide by negative 2/3, which is just multiplying, right? So this is actually just multiplying by the reciprocal. So negative 3/2. This is 1 in 100. So this is actually negative 300. So negative 300 kilograms is our mass. Now, tell me if that makes sense. It doesn't make sense, okay? But that doesn't mean the answer is necessarily wrong. This number is correct. 300 kilograms is equal to the mass, but it's not reasonable to have a negative value because it's the same thing with time. If you were to get a negative time, that doesn't make sense. A negative mass also doesn't make sense. So you're just automatically going to want to convert that to a positive. All right, so a 100 kilogram object initially at rest is pulled with 3 constant forces of 150 newtons east. So this automatically is calling for a diagram. So let's draw it right here. This is 100 kilograms. And we're going 150 newtons to the east, 100 newtons at 30 degrees east of south. So that might sound a little bit confusing for you guys. So what we're going to want to do, 30 degrees east of south we're going to want to draw south first. So this is south, right? But we're going 30 degrees to the east, which is to the right, right? So to the right of the south, and we're going by 30 degrees. So this right here is 30 degrees, and this is the force. So 100 newtons, 30 degrees east of the south mark right here. And 175 newtons at 60 degrees north of west. So this is west, and we are going 60 degrees north of that. And that is 175 newtons. What is the net acceleration on the object? So what we're trying to find is ultimately where is this object going when there's like 3 different people pulling on this with different amounts of power and or different amounts of force, and which force will end up being like how much force in what direction is this box ultimately moving in. So basically what we're gonna have to do is we're gonna have to convert all of these into x and y components, just like projectile motions. So this 150 newtons is super easy. It's going to the east, so it's a positive 150 newtons, and there's no y movement, right? So simple, done. These two are a little bit more challenging. We have one going to the right and one going down, right? So our to the right, this is our x, right? But x is going to be 100 newtons sine of 30, because this x is actually on the opposite of this 30. And what that ultimately gives us is going to be 50 newtons. And then our y can be found using 100, and this is adjacent to the 30, so cosine of 30, and that is going to be negative 86.6025 newtons. Now, we need to do the same thing for this one. So this is going to the left and up. So this x is actually going to be negative, but then the y is going to be positive this time. And this left is adjacent with the 60-degree angle, which means x is going to be 175 cosine of 60 because it's adjacent, and y is going to be 175 sine of 60 because it's opposite. And this ultimately gets us negative 87.5 newtons and a positive 151.554 newtons. Now what do? Is it's a net acceleration. Right now we're finding the net force. The net force is just adding these components up, which is going to be 112.5 newtons on to the right and 64.952 newtons upwards. So this is basically like coordinates, right? Now, what we need to do is this basically is going 112 this way, 0.5, and then it's going up 64.952, whatever. But this is the actual vector, is the hypotenuse of these. So how do we find C? Well, it's the Pythagorean theorem. Wow. That's nuts. So what are we going to do? 112.5 squared plus 64.952 squared is equal to C squared. What's that going to get us? It's ultimately going to result in C equaling 130 newtons. And there we go. So that is actually our net force on the object. And how do we find out what the degree on this is as well? Well, this is going to be a certain amount of degrees north of east is going to be our answer, okay? So this is what we're going to do. We are not going to use C. We'll just still use the numbers that we got here. And we're going to use tangent. So tangent of theta is this angle right here, is equal to opposite, right? Opposite is the 64.952 over adjacent, which is this 112.5. Now, to isolate this theta and get the actual angle, we're going to use inverse tangent 64.952, and you guys should be able to see this button on your calculator. You might have to use the second button. Hit the second button and then hit tangent. And then that's how you find theta. So our theta ends up being equal to 30 degrees. So what happens is, what we just got is this 130 newtons and 30 degrees. So how do we write that answer? Well, let me make us some space here. This answer can be written as 130 newtons, right? Like these ones. And it's going to be at, just write it the same format as the question, at 30 degrees north of east. And that is our answer, because this was the hypotenuse. So this is our east, and we're going north of this east, right? And we're going 30 degrees, and specifically north of east, at 130 newtons. So that is our net force. But we want our net acceleration. So our net force is 130 newtons. Well, it's just going to be 130. F is equal to ma, right? Times our m, which is 100. This times acceleration, just divide by 100, divide by 100, which means we get 1.3 meters a second squared is equal to our acceleration. And there's our net acceleration on the object. So we found net force, the directionality, and the net acceleration in this problem. So you guys should really understand vector forces now. See you in the next video.